Hi everyone. This may not be as coherent as the other lectures because I think you know why. The last thing we need to learn about before you guys take your quiz on Thursday is the last page of your notes. And on that last page it said, how do we combine localized orbitals? Let me take a second and explain what localized means again. Localized means that the electron density is shared between two atoms and only between those two atoms. They are locally located, localized. Molecular orbital theory is where we talked about the hybrids that you guys have been discussing, which reminds me I need to give you all the answers to those worksheets. And genius me, I cannot find them anywhere, so multiple levels of disappointment. I'll text Steve if he's still up. So molecular orbital theory using hybrids, this is going to allow us to have electron sharing that is not between just two. You might remember me talking about that in resonance. So let's get into this. Look at the example here of benzene in your notes, C6H6. Benzene is a 6-carbon ring with one hydrogen. See it? It's got 6 carbons in a ring and one hydrogen coming off of each. So in picture A, what you see is carbon not having its octet. In picture B, when we go to fulfill the octet, let me zoom in here. When we go to fulfill the octet, notice that we have a choice, double bond to the right, double bond to the left, and that's what's called resonance. So you guys remember that, I'm sure. So this results in resonance. What we're going to say is this, and this is basically what's being shown in the picture. Notice that on this atom, that carbon right there that I'm pointing at has 1, 2, 3 domains. It would be sp2 hybridized, which is the definition of trigonal planar, but because it's sp2 hybridized, please remember, hybridized orbitals cannot double bond. They can only single bond with a sigma overlap. That's what they're showing you here, the trigonal planar sigma overlap. So look at trigonal planar carbon next to a trigonal planar carbon next to a trigonal planar carbon. These are all localized, okay? So that overlap right there between the hydrogen, that little tiny sphere is a hydrogen, that is localized to that lobe on the carbon. So it's only between those two. And that lobe overlap is only between those two carbons right there because his lobe is overlapping that other lobe. Now, all of those single bonds, the single bonds of the hydrogen to the carbon are going to be called sigma, right? Because single bonds are sigma overlaps only. But then how are we getting these double bonds? And that is happening because, guys, if I'm sp2 hybridized, that means one of the p's is not hybridized. So sp2, but p's got 3 orbitals. One of them didn't hybridize. So look at them. I'm going to zoom in. Go ahead and look at them. Every single one of those carbons has an unhybridized p, and look at what can happen. Overlap above and below the axis between each of the carbon atoms such that it's going to resonate. Look at that beautiful picture of resonance. It's resonating above and below the axis such that the bonds on benzene are not single, nor are they double. They are all equal in length, equal in strength, and somewhere in between a double and single bond. So this is called delocalized because that bond doesn't just belong between those two. Why can't it go to those two? Why can't it go to this guy? Why can't it go to this guy? Why can't it work like our telephone network and always be transmitting all around us? Because that's how Wi-Fi works, right, guys? So that's what you need to think about when you think about delocalized, is that if I create a hotspot using my phone, You can sit anywhere near the phone and get that access. So that's what delocalized means. But localized is what happens with sigma bonding, and delocalized is what happens with pi bonding. So guys, be prepared for a question. I guarantee you on the test there will be a question. You will be asked to draw the Lewis dot structure, predict the VSEPR shape, predict the hybridization of the central atom, and from there explain how the resonance is possible using localized and delocalized electron theories. I hope everything's going okay. I will see you next Monday, and I look forward to seeing you, and I wish you good luck on your quiz. It really is easy as long as you guys have got the right answers, and I will try my best tomorrow night to get those answers to you in the evening. Please, could somebody text me and remind me of that? All right, love you guys. Bye.